We use it every single day, right? For work, for fun, for pretty much everything. But what is the internet really? I mean, how does it actually work? Okay, let's dive in and really pull back the curtain on this incredible network that connects our entire world. Think about it. You type in a web address, you hit enter, and poof, a website just appears. It feels totally instant, like magic. But behind that one little click is this lightning fast journey that's happening across the globe. And today, we're going to follow that journey from start to finish. So, to really understand what the internet is, we first have to get where it came from. It didn't just pop up out of nowhere. The whole story actually starts more than 50 years ago as a government project with a totally different goal in mind. It all kicked off back in 1969 with something called ARPANET, which connected just a couple of university computers. But the real game changer came in the 70s with TCP/IP. Think of it like this. It's a set of rules that became the universal language for all computers. Then, in 91, we finally got interfaces that normal people could actually use. But the Big Bang, the real explosion, happened in 1995 when businesses were allowed on. And by 2009, 4G put that entire powerful web right in the palm of your hand.
Okay, so that's the history, but that still doesn't tell us what this thing is. So let's get to the core concept, the really big idea that makes the whole thing possible.
So at its heart, the internet is just a network of networks. That's it. It's not one single entity. It's this massive, sprawling collection of all the little networks. Your home Wi-Fi, the network at your office, the giant systems at Google, all of them linked together, all speaking that same digital language, TCP/IP. And this is the perfect way to picture it. Imagine your group of friends is a network. You can all talk to each other. No problem. Now, what if you could connect your friend group to every other friend group in the world? All of a sudden, anyone can talk to anyone else, no matter where they are. That's exactly what the internet does, but for computers. So how does a photo or a video actually get from one place to another? Well, every piece of data is shattered into tiny little pieces called bits, which are just pulses of light or electricity. These bits then zip through thousands of miles of physical wires, undersea cables, and even through the air as radio waves, all at pretty much the speed of light. And when we talk about internet speed, it's really just about how many of these bits can be crammed down the pipe at the exact same time. All right, now for the main event. We are going to trace the exact step-by-step path your request takes, from the moment you type in a web address to the second that page loads right on your screen. First, let's meet the two main players in this little drama. On one side, you've got the client. That's you, on your phone or your laptop. Your job is to request stuff. On the other side is the server. That's a powerful computer out there that stores the website you want. Its whole job is to serve you that information when you ask for it. Okay, so you open your browser and you type in something familiar, something a human can easily read, like Google.com. Simple, right? That's our language. But here's the thing. Your computer has absolutely no idea what Google.com means. Computers don't speak in names, they speak in numbers. To find anything, your computer needs a very specific numerical address, called an IP address, like this one right here. Every single device on the internet has one. So, how does your browser get from the name you understand to the number it needs? It uses the DNS, the Domain Name Server. And the DNS is literally the internet's phone book. Its entire job is to look up the name you typed and find the correct IP address that goes with it. Without DNS, we'd all be trying to memorize long strings of numbers for every site we wanted to visit. No thank you. Okay, let's put it all together. Step 1, your browser shouts out to the DNS, "Hey, what's the number for this website?" Step 2, it sends a little message, an HTTP request, to that number, basically saying, "Can I see your page, please?" 3, the server on the other end says, "You got it," and sends back a 200 OK. 4, the server then starts firing the website at you, but in tiny little pieces called data packets. 5, your browser catches all of these packets and starts putting them back together in the right order, like a puzzle. And finally, 6, boom, the web page appears on your screen. And all of that happens in less time than it takes to blink. So that's how the internet works today. But its sheer scale is about to change in a way that's, well, it's pretty hard to wrap your head around. Let's look at what's coming next. Right now, there are about 3 billion of us connected to the internet. That's a massive number. It's almost half of all the people on Earth. But by 2030, that number is expected to more than double to 7.5 billion users. We're on the verge of the internet becoming something that connects nearly every single person on the planet.
But, and this is the really wild part, the number of people getting online isn't even the biggest story here. By that same year, 2030, projections show there will be 500 billion devices connected. We're not just talking phones and computers. We're talking cars, refrigerators, watches, traffic lights, everything you can imagine. So here's the thought I want to leave you with. The first 50 years of the internet were all about connecting people, and it completely reshaped our society. The next phase is about connecting things on a scale that is hundreds of times larger. So what happens then? What kind of world does that create? That's the big question we're all going to be answering together very, very soon.